very interesting concept, and I'm sure that you are also very much familiar with the tendency of a shift reduce parser, right? So from today itself, today we are going to finish one parsing that is called as top down parsing. We are going for top down parsing. uh, like, see, if you look at parsers, uh, you know that these parser are broadly classified into two classes, right? So that is called as top down and bottom up. Okay, so bottom up are again being classified as, like, say, they have certain types. First is you can go with the shift reduce, which we have seen, shift reduce. Then second class of grammar which we have seen is uh, LR parsing. Okay, and then this LR parsing is being broadly divided into SLR, that is LR0, then it is LR1, this is called as CLR, and the next is LA LR, this is called as LRK. Okay, then you have actually another grammar, that is OPP, operator precedence parsing. Okay, so this is the only grammar which handles ambiguity. Huh? For rest of the grammars, you need not, the rest of the grammars are not able to handle the ambiguity of the expression. Okay, so in case of a top down parser, we have a parsing method called ll1 which we wanted to study. So this is ll1. So if we mark that total parsing method, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So total 6 parsing method we are going to see. So out of that, our discussion on this is over, on this is over, on this is also over. Okay, and broadly we can say, in case of bottom up parser, it is rightmost most derivation in reverse. Okay, okay, what does it mean? It means that we start with input symbol, and this input symbol is being substituted with the leftmost leftmost non-terminal. So we started with rightmost input symbol, and we try to get the leftmost appropriate non-terminal. So which means that if there is a production of the if there is input symbol, say id plus id. Okay, so we'll say that, okay, id is to be replaced by e if the grammar is e implies E plus E or ID. So we started with ID. ID is pushed onto stack, then it has to be reduced to E. Then you have got again this ID. ID is to be reduced to E. Then we know that E plus E is nothing but E. So means what? The top of the stack is the leftmost non-terminal. And in case of a general shift reduce parser, or in any case of duration, so uh, start symbol followed by dollar is going to our accept condition, right? So this is means, like, when we announce a successful completion, when the start is followed by dollar, then that is a successful completion. Okay, now look at this. In case of top down approach, the method is little different. Okay, in case of top down parser, we have to go for a method that we are starting trying to produce the words from the start symbol. This is important. So means it is left to right, right? This is left to right we are going from, like when it is left to right, it is, in case of top down parsing, we are going for left to right. So left to right means what? We are starting with non-terminal, and we try to identify the flow or a sequence by which the input symbol is generated. Okay, so this is the case. So we are going from left to right, and the flow or oblique the sequence by which the input symbol is generated. Now, just to understand this case. Okay, now how this is going to happen? So if you have a production, E implies E plus E or A. So and if I want to produce E plus A or A plus A, if my input string, say for example A plus A, and I want to produce, this is just an example, huh? This is just an example. Like we are trying to understand like how we start with the leftmost terminal symbol, non-terminal symbol, and produce the input string. That is what, for understanding that we have taken. But if we want to go for an exact top-down person, there are certain criteria which we will see. Okay, so E implies E plus E. So we'll say E, we start with the leftmost non-terminal, then E is being substituted as E plus E because it has two alternatives. This is first alternative, this is second alternative. So we'll say this, we have done this by the first production. So it is E plus E. So we'll say this is by first production, first alternative. Then this E is ID, this D is ID. Then this is by E implies ID, and this is by second production. Okay, but now the case is that when we are going to we are going for this kind of process, means we are starting from the leftmost non-terminal, trying to produce an input string. What is important here is stack. Okay, what is important here is stack. So which means that see, when I say on the stack E is there, so it is being placed as E plus E. Right, so this is going to be top of my stack. This is going to be a of my stack. So this E is to be substituted. This is being substituted as, say for example, if my input string is say ID plus ID, so the top of the stack, which is this, has to be substituted with the production values. So what is that production values? E is A, right? So if my input string is A plus A, so E is to be substituted as A, so which means that is going to be A. Okay, so since this is A, this is A, right? So this gets matched, so this gets popped off, right? And this is being removed, right? And you have substituted already, you made it so, right? Whatever is expected, you got it, so you popped off. Then what is remaining is top of the stack is plus. Okay, so plus is already there, so it is being matched and popped off. Okay, so what is on the top of the stack which is remain is E. So E has to be substituted by A. So E has to be substituted by A, input string get matched. So what is available on the stack is dollar. Okay, so means this is how you have prepared. But now the thing which you need to understand is like how it is being kept onto the stack. Okay, so this is how it is kept onto the stack. And worth noting part is like if you have a stack something like this, so your top lies here. This is the case. So top. So every time, say if for example E implies TE dash, if this is the production, then how we are going to write on the stack, say for example A, this is E dash T. So it's TE dash. So T has to be onto the top of the stack. So how we are going to write TE dash, right? In this way, but this is going to be top of my stack. Okay, so understood this particular point. It is very easy that in case of top-down parsing, what we are going to do is we are going to start going to we are going with left to right, so which means uh, uh, from root to the leaves we are going. So the from left to right, what is at the left? The left is leftmost non-terminal symbol, maybe the start symbol of your production, right? So you will be starting with the start symbol of the production and trying to produce the string from it. So this is being done by actually substituting the non-terminal with its corresponding productions, right? So that you can match the input string and you can parse it properly. Okay, so this is the case. Now once you have gone for understanding this, like how it is being done, you need to go for top down parsing. You need to understand the key pointers. Okay, key pointers, what are they? Right, first, what are the criteria? First first criteria is uh, uh, top down parsing is not applicable on, not applicable on left recursive grammar. Okay, so top down parsing is not applicable on left recursive grammar. So top down parsing is not applicable on left recursive grammar. So you first checkpoint is if you have got a grammar, then that grammar has to be checked for left recursion. If it is having a left recursion, then you need to remove the left recursion, right? So this is really very important. So it's not applicable onto a grammar having the left recursion. So this is most important key points. Not applicable on left recursive grammar. So if your grammar is left recursive, you need to eliminate left recursion and proceed for parsing. And why it is so? Say for example, if your grammar is say E implies E plus E, okay, or A. So in this case, what is going to happen? E is E plus E. Then what is E? E is again E plus E. This is again E plus E. Okay, so this goes into expansion of left recursive grammar. So this is going to be critical, and you cannot produce or you cannot handle this, right? So it is really very easy if it will be a non-recursive grammar, non-left recursive grammar. So the key pointers what you need to understand is this, that first is if the grammar is being provided to you, you need to eliminate the left recursion. Now for example, let us try to understand this with example. Okay, then the key pointer is like, okay, you need a stack, you need a stack for all your reduce actions, right? So whenever you are going for performing a reduce action, it is pop. Okay, and you go for shift, which is nothing but push. So you are trying to push the element onto a top of the stack, and then you are going to reduce. So it's like the architecture is something like general shift reduce architecture, right? So, and which is known to you. Okay, so let us try to have an example. If you look at organization. Okay, if you look at organization, then the organization is again a really very easy organization, and this is the way the general organization is. It is in that particular way only, right? And we have familiar with that particular organization of the parser. So let me draw this picture for you also, like how this is going to be. So this is going to be your input string. This is your input string. Okay, then what you have, you need to go with parser, and what you need a stack. The same architecture. So this is going to be my stack. This is going to be input string. Okay, so input string stack. Okay, then what it has two things here. This is called parser routine, and this is called as what? Parsing table. Okay, so key pointers, what you need is here is like when you go for top down parsing, you need to prepare, you need to represent stack also, and you need a parsing table also. Okay, so you have to go for stack and parsing table, don't forget this. Okay, so you have your input string is going to be here. Okay, now let's see if your grammar is a very interesting and simple grammar. If your grammar is E implies E plus T or T implies T star F or F implies opening bracket E or A. Okay, so once you have got a grammar, once you received a grammar, right? Then this grammar has to be checked for left recursion. If there exists a left recursion, then what you need to do? So is this contain a left recursion? Yes. Okay, so let me put this left recursion concept to you also. Left recursion. Okay, so very simple. Left recursion means when the start symbol is appearing at the first place, right, in the production at right hand side. Okay, so when the start symbol is appearing at the first place in the production at the right hand side. So now see, start symbol is E appears at the first place in the right hand side of the production. So if it does, then it ultimately calls for left recursion. So this is a left recursive grammar. So means what? If there is a production of this particular form, like A implies A alpha. If there is a production, A implies A alpha, A is a start symbol, A appears to the right hand side of the expression. If there is a production in this particular form, this is a left recursive production. So don't forget this rule, right? So keep this rule in your mind, that what exactly if it is a production like this way, or you can say A implies A alpha or beta if this is the production. Okay, so if this is the production, the first alternative is carrying a left recursion. Okay, so you can say you just try to convert this left recursion into a non-left recursive part. So it is like E implies te dash, E dash is plus te dash or epsilon, then T implies f t dash, t dash is star f t dash or epsilon, f implies opening bracket e or a. So this is what is non-left recursive. So this is grammar, right? And this is by elimination of left recursion. So this is by elimination of the left recursion. So this grammar you are going to go further. Okay. So let me give you the production number. This is 1, this is 2, this is 3, this is 4, this is 5. Okay. So this is E implies epsilon. This is 2.1. You can take t dash m, e dash implies epsilon is 2.1, t dash implies epsilon as 4.1. F employs A as 5.1. You so like in case if you want to write that as a number, so in that case you can do. Okay, so this is going to be now for this your input string is going to be your input string is dollar a plus a star a dollar. So this is your input string. So what you need to do here is you need to prepare a stack. So first step, this is say first step, this is say second step. You have got an input string, this is third step. Now fourth step is stack representation. Okay, so which you have got, right? So stack representation. So let us recall the concept of stack representation at LR parsing. What you have, okay, so you have got some action part, input string and stack. So this is going to be for this also. So you have got stack, you have got a input string and you have got a action, right? So the stack, input string and action, and at the same time we will try to prepare a parsing table also. Okay, so you can understand that also. Okay, parsing table. So now when you are trying to draw a parsing table, you have to take certain thing into mind. Okay, so your all terminal symbol should go into the column wise, and all non-terminal should go here. Okay, so what are those non-terminals? Say, for example, those non-terminals are say E, right? Then E dash, T, T dash, and F, right? So all your non-terminals are here. Okay, E, E dash, T, T dash, and F. Okay, then uh, your production will be like, say in this case, not your terminal symbols are like this is how your terminal symbols are. Say for example, this is going to be plus, this is going to be star, this is going to be, now what is left is opening bracket, closing bracket. Okay, so this is what exactly it is. Now in our example we have a plus a and star a. Okay, so this is what exactly it is being done. So let us try to have an input string, say dollar a plus a star a. Now what you need to understand is when you push, the top of the stack is going to be dollar, so what is left is a plus a star a. Okay, and dollar. So in this case you need to see like, okay, I have to go in this way. So the point is like how I can reach to this. So what is left is, oh yeah, what is left is one more point which is left here. mm, is okay, I will say this is a, this is closing bracket, and this is opening bracket. Okay, opening bracket and closing bracket. Okay, now how I can reach to a? So reach to a is like, if it is a in the input string, I need to go with the um, production of a. So I have to write say I have to write say e implies, as far as this is concerned, e implies te dash, right? So e implies te dash. Okay, then what is t? T implies ft dash, right? T implies ft dash, right? Just a minute. Okay, T implies, T implies F T dash, and F implies A. So it means here what is going to happen. So E implies, so at the first thing it is going to be E, then the top of the stack is being substituted by its production. So it is again nothing but dollar E T E dash. So E dash T. Okay, so it is A plus A star A dollar. Okay, then it is FT dash, right? T is FT dash. Okay, so it means dollar E dash T dash F. So are you getting my point? Like now, what is top of the stack? Top of the stack is F, right? And F is being substituted as A, so it means dollar E dash T dash A, and now what you have got, A plus A star A and dollar. So here what you are going to go for, okay, you produce this A and this A, so what is left is A star A dollar. So means what, you reach to this particular symbol, right? You reach to this particular symbol, so this got popped off from the stack. So remaining representation is E T dash plus A star A dollar. Okay, now what is what is left is what is left is E, uh, right? Sorry, this is, okay, this is E dash, right? Then what, how you can go for plus T E dash? So in case if you look at this, T E dash, T dash is epsilon. So means what, means what, you can go with here, like you can go with okay, here epsilon. So you can write T dash is epsilon. Okay, so T dash is epsilon. So you have to go for, if T dash is epsilon, what is left is plus A star A. So here dollar E dash is plus A star A. So here we are going to write T dash implies epsilon. T dash implies epsilon. So okay, so E dash is what? E dash is now plus T E dash. Okay, right? E dash is plus T E dash, so it means dollar E dash T and plus. So here what you have got, plus A star A dollar. So ultimately what is going to happen now, for plus and with the for plus with E is here, right? For plus with E dash is, for plus you need to write E with the plus. E is going to be, how you can go for E with the plus is E dash implies plus T E dash. Okay, so this is how you have marked this particular entry here also. Okay, so this is, you got plus here, plus here. Now this is plus plus, you need to reduce it. So you can go with, what is left is dollar E dash T. Okay, so it is A star A dollar. So then dollar T is what? T is FT dash, right? So T is FT dash. So T is FT dash. You can say T is FT dash. So you need to write here E dash is T dash F. F is A star A and dollar F is A. So you need to write F is A. So this is going to be reduced. So dollar E dash T and F. F is A. So F is A. Here you need to write A. So A dollar star A. So this got this. So now you have got T. Okay, you have got, right, you have got this T dash here, right? So T dash here, right? So this is T dash, T dash. So you have got A removed. So what is left is say dollar E dash T dash. Okay, star A and dollar. Okay, so now here, in this case, so here in this case, what is left is this. Okay, so means what for star, if you look at T dash, for getting a star, so we need to write like if T dash with star, if we are going, then we have to write T dash is star F T dash, right? Okay, T dash is star F T dash. So it is in this case what we need to write here. As far as this is production is concerned, we are going to write it here something. So dollar, okay, dollar E dash is now it is star F T dash. So F T, right. So it is star F T dash. So it is star. Just a minute. Just wait a minute. Just need to. Okay. So what we are going to write is it is ft dash, right? So this is t dash f and star. So here it is star, then a dollar. So this star gets popped off. So what is remaining is a. What is remaining